Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to extend the concept of the geographic center to include what's called a weighted value. As this is going to be a weighted center. Right. And so what a weighted center does is it gives you the opportunity or the option to not calculate the geographic center based just on the coordinates, but to now include some variable or some value from the attribute table that you might want to impact your center. And so a good way to think about this would be to, again, imagine that we're trying to find the location of a town hall, right? But we want to prioritize locations that have a lot of people, right? Maybe it might make more sense to give more weight to large apartment buildings because that's where a lot of people would be coming from than the 2-bedroom house on the edge of town, right? Under the normal geographic center, right, those would be given the same amount of weight because they're just points. But the idea with a weighted center is that we can use some value to give more weight to locations with higher values. So again, right, we would be able to shift that center towards, in this example, right, towards heavily populated apartment buildings, for example, right? Or if we're dealing with crime, maybe we want to place a police station weighted more towards, heavily high crime areas or areas that have high crime, as opposed to just leaving all of the locations equal. Right. But so in order for us to do a weighted center, we have to go back to our concepts of geographic center and modify the equation slightly to be able to accommodate this value. Okay. So what I've done is I've got the same set of points. Again, I've just changed the arrangement slightly, and I've included this value. And this value, again, is arbitrary. These are random numbers, but you could imagine them representing something like the population, or maybe it's the amount of crimes in a given area. But what we're going to do is we're going to take this value, which is going to be an interval or a ratio data set, right? So when we go back to the idea of categories of numbers, we would want these to be either interval or ratio, because we're going to apply these as a weight to move our center around. So just like before, I want to start our conversation by talking about weighted mean. Okay, so we're going to take the mean and we're going to add weight. And so what we're going to do, just like before, we're going to calculate an x coordinate. And I'm going to mark it with an x bar sub w so that we know it's weighted. And we're going to do the same thing with the y coordinate, right? Y sub w so we know it's weighted. So this equation is going to look very similar to what it was before, with a couple of differences. So the first thing you're going to notice in the equation is that we're going to sum from I equals 1 to n, just like before. But we're going to sum the x sub I, so it's the x coordinate, times the weight sub I. And this weight sub I, this is going to be the value of that point. Right, so this w sub I is going to be the value associated with the point. So when I is equal to 1, right, x is going to be 2, well, this w sub I is going to be 514. Okay? And then we're going to divide that not by n, but by the summation from I equals 1 to n of w sub I, right? Where again, this is the value of the point. So essentially what we're doing here is we're summing up the x coordinate times its weight, and then we're dividing that by the total sum of the value, right, of whatever variable we're interested. We're summing up that column, okay? And then I'm going to copy this down here, right? Y sub w, so this is the weighted y. It's going to be the exact same thing. We're just switching out the x's for the y's. Right, so it's going to be the summation from I equals 1 to n But in this case, instead of x sub I, we're going to be doing y sub I times w sub I over the summation from I equals 1 to n of w sub I. Right, so it's going to be the exact same thing, except instead of looking at the x, we're going to look at the y. So again, if I was equal to 3, just to make sure you understand this, right, if I was equal to 3, it would be the third point's y coordinate, so it'd be this 7, times the third point's w coordinate, which would be 787. And we're going to add up all of those combinations divided by the total sum of the value column, okay? So what I want to do is I want to look at an example of this, but again, because it's a lot of just keeping track of numbers, we're going to pop over to an Excel spreadsheet. Okay, so what we have here is the same thing as we had before. We have our x coordinates for all of the points. We have the y coordinate for all of the points. And then we have that value, right? This random number that represents something, right? It could be anything we want it to be, okay? And then so what I've done here is this x times value column. This is literally just multiplying, right? It's that first half for x first, right? The top half of that equation was, x sub I times w sub I. Well, all that is that's the x value times the value for that location, right? So in this case, it's multiplying the x coordinate times the value, right? If we go down here, right, it's multiplying the x coordinate times the value, right? All the way down to here, right? X coordinate times the value. Okay. And then down here, right, this is the total, right? It's just adding up all of those x coordinates times values, right? That's what that top half of the equation meant when we were saying multiply the x coordinate times the value and sum them up. So this is the top half of that equation for weighted mean, right? The second half of that equation was that sum of the values. So that's what this is, right? This is, if we take a look here, right, this is just adding up all of the values for the data set. So this is that sum of wi that was the bottom half. So this is the top half, this is the bottom half, right? So to get that weighted mean for x, all we had to do was divide them, right? And that's what this is doing. It's taking the total of the value times the x coordinate, and it's dividing it by the total of just the value. And we get a weighted mean of basically 5.5, basically, rounded. Right? And if you remember to our original equation, right, our original mean was 5.3. So you can see that we have actually adjusted the mean slightly. And then we do the same thing over here for the y's. We have y times value, so this would be this 10 times 514. That's why we get 5,140, right? Down the line. Here, again, we're summing this, so this total is just all of those numbers added together. And then the mean, right, because we're figuring out the mean y coordinate, is just this value here, right? The summation of the multiplications divided by the summation of just the values. And we get 5.94. Okay? So again, just to reiterate, all we did, multiplied by value by coordinate, multiplied y value by coordinate, summed them up, and then divided by the total of just the value to get the different means. So let's go ahead and pop back over to our paint here. And let's go ahead and add that mean to our data set. So we said that it was approximately 5.5. So if this is 5, halfway there is going to be 5.5. And then 6. Right, it's going to be like, right there, because it's slightly under 6. Right, and then our old mean was 5.33, so it's going to be slightly less. It's going to be roughly, how about we do orange, right? It's going to be like roughly right here. Right, so you can see here that by weighting the mean, right, we pulled it closer to these values that have higher values, right? Because this 710 had a high value and this 210 had a high value. And so you can see that we've shifted the mean slightly by accounting for the weights. So again, right, by multiplying the coordinate times the weight and then dividing that by the sum of the weights, we're able to give weighted preference to some particular attribute that we care about. And again, a good example of this would be trying to incorporate population so that you shift that mean based on areas that have higher population. Okay? So hopefully this made sense. Hopefully this slight adjustment to the equation made sense. And if you have any questions, as always, please reach out. Thank you.